Thank you. My name is Feng from Oslo Metropolitan University. Today I'm going to present a paper called Aging at Home, a secure 5G welfare technology solution for elderlies. The work is done by my colleagues at the Oslo Metropolitan University and Telenor and Wolffia. The motivation of this work is that the world population is aging fast, and the need of efficient digital solution enabling elderly to age at home is getting urgent. This is so far no such solution which is sufficiently efficient, customizable, secure, and reliable. So our paper presents a solution called Aging at Home, which aims at enabling newly hospitalized elderly to come home earlier by making use of a dedicated 5G network slice for healthcare system. Such an isolated logical network will provide adequate security, privacy, and reliability for the selected welfare technologies and services deployed at the elderly's home. The proposed solution allows the selection and customization of needed welfare technologies and services and promotes the reallocation and reuse of equipment. Validation methods and the business plan have been presented, as well as a thorough description of a proof of concept implementation. The outline of the presentation is, after a short introduction, we present the state-of-the-art of digital solutions to smart living environments for aging people. And before we introduce our Aging at Home solution, we start with a short introduction of what the 5G network slicing is. And we also present the validation methods and the business plan. And before we conclude, we'll present a proof of concept implementation. So the introduction. The aging population brings significant challenges, both to the elderly citizen and for countries all over the world. It leads to significant challenges such as increased dependency rates, overload of healthcare systems, lack of elderly homes to provide support, etc. The use of new technologies to provide the necessary needs and assistance to senior citizens, such as they can live at home as long as possible, is by far the most economical and sustainable solution for the whole society. It is essential that they can live comfortably, safely, and securely at home. Different welfare technology solutions have been proposed, but they are still suffering from many major limitations, such as instability, deployment difficulties, poor usability, and high cost. We present Aging at Home, a 5G-based solution which addresses the mentioned weaknesses. Now, the state-of-the-art of digital solutions to smart living environments for aging people. There are many research activities in the European Union and Nordic countries, such as Active Assisted Living Program, Nordic Ambient Assisted Living, and projects under umbrellas of COST and Horizon 2020. So far, these digital solutions still have quite low uptake due to the following limitations. The first is the low technology maturity. Since many systems faces problem of instability because the wireless LAN experience occasional loss of connection due to interference, channel collision, coverage variation, etc. And they also face the configuration complexity because you need configuration of several parameters for each installation. It's easy to go wrong, and further, security protection requires considerable knowledge and efforts. Also, they face the installation difficulties. The installation of sensors and devices at the elder home could be difficult due to the furniture, time-consuming, and annoyance to the users. More limitations like fragmentation, which means that current digital solutions are silos applications that operating in isolation without interworking and interoperability with each other. Consequently, the introduction of additional services will require a full installation of hardware and software, which incurs high cost and disturbance to the elderly. They also face lack of user centricity because they are too much technology oriented, consisting of a bunch of technologies that are put together and offered to the elderly without sufficient considerations of the elderly users' preferences or the health personnel's opinions. In addition, we also have some issues with the security and privacy. Like, also it's necessary to collect data to provide effective services to elderly. These data are personal data, which illegal access constitutes a privacy violation. Unfortunately, the protection of personal data is currently not adequate. Also, the use of video camera has been considered as obstructive by elderly who feels watched. Now we introduce the 5G network slicing. 5G, the fifth generation of mobile networks, it's well known for its superiority compared to 4G in terms of performance, coverage, and quality of service, and the promise of enhanced mobile broadband with higher data speed and support a wide range of services and applications, ranging from massive machine-type communication to ultra-reliable and low-latency communications. Less known but not less important is that the fact that 5G is a softwareized and virtualized network. Indeed, a 5G network is not made up by physical network elements as traditional mobile network, but of software virtual network functions. The figure shows the logical architecture of the 5G network slicing. The 5G system divided the network into the control plane and data plane. The software nature of the 5G enables the realization of the network slicing concept, which can be defined as by the 5G PPP that we'll show on the next slides. It brings with it both weaknesses and strengths, since it shows the same vulnerabilities as any other software at the same time as higher flexibility and dynamicity can be achieved through the logical network segments, also known as network slices. Currently, there is no consensus on what a network slice is and how it can be realized. In this paper, we use the 5G PPP's definition that allows the support of a variety of devices to obtain a wireless home networking capable of supporting a broad range of devices. The 5G network slicing concept is adopted to establish a secure 5G network for elderly care. The 5G PPP stands for the 5G Infrastructure Public-Private Partnership. They adopt a business-oriented view, mandating that a network slice is a composition of adequately configured network functions, network applications, and the underlying cloud infrastructure, physical, virtual, or even emulated resources, RAN resources, etc., that are bundled together to meet the requirements of a specific use case, e.g. bandwidth, latency, processing, and resilience, coupled with a business purpose. The main objective of the Aging at Home solution is to enable newly hospitalized elderlies to return home earlier by providing a set of welfare technologies and services deployed at their home, provide efficient support and assistance from the healthcare personnel. Aging at Home solution can also be used permanently or temporarily for the time needed towards full recovery. The deployed equipment could be easily removed and relocated be collected for reuse by other elderlies. As such, aging at home can be used in a dynamic and customized way for any elderly who needs assistance from healthcare personnel while living at their home. Here is a list some of the welfare technology and services used in the aging at home concept. One is a vital sign monitoring system. Monitor vital signs such as heart rate, body temperature, respiration rate, blood pressures, etc. And it can also be, another is reminding system, helps elderly to remember to take their medicines and meals, etc. And automated activity and fall detection system, which can distinguish between normal and abnormal activities and to detect a fall to trigger an alert, which can again result to an emergency with intervention of caregivers. Another service is automated emergency call system. It can locate, contact, and detect the nearby appropriate caregiver who gives assistance to the elderly person in emergency cases. It also can offer multimodal communication by providing secure remote medical checkup calls with doctor, medical staff, secured interaction with the healthcare system, including notifications and alarms, at the same time as it helps to combat isolation and loneliness by allowing elderly to communicate to friends and relatives. Let's take an example. Consider the case of an elderly named Kari, who had a successful heart surgery and is allowed to come home after 4 days instead of 1 week. Her vital signs, glucose and breathing status are monitored, and also assistance can be given on time at occurrences of incidents such as loss of consciousness, fall, heart attack, etc. In addition, Kari suffers of sleep disorder, which needs to be diagnosed. Kari also needs a secure communication facility, which allows secure interaction both with the hospital and also with her family and friends. To be safe at home, the following technologies should be in place. The sensors for monitoring of vital signs, glucose, and breathing. And sensors for detection of incidents such as loss of consciousness, fall, heart attack, etc. And also need a tablet PC acting as a secure communication with the hospital and for contact with family and friends. It should also be a secure and reliable connection to link the sensors and equipment to the hospital system. As the majority of elderlies, Kari does not have the necessary sensors and equipment, nor the secure and reliable connection needed. But thanks to aging at home, all the necessary equipment and infrastructure can be identified, allocated, configured, and installed at Kari's home short time before her return. The rollout consists of the following steps. 1. Visit and assessment of the technology infrastructure at her home by technology specialists. Design a configuration of the necessary equipment such that they will be functioning immediately after power on without any on-site configuration. And design establishment of the connection to the healthcare network slice. Depending on the availability of broadband connection at Kari's home, one connectivity alternative will be chosen among 5G fixed wireless access, indoor radio unit, or 5G enhanced mobile broadband. This figure shows the aging at home conceptual architecture. We see that multiple sensors are connected to Open IoT via 5G or sensor gateway. The data can be forwarded to aging at home apps, AI and ML platform, or the healthcare system. The AI/ML platform has interfaces with the Ageinghome apps and the HCS, which are then enabled to invoke various analytic tasks. The interface between the Ageinghome apps and the HCS enables the Ageinghome apps to access the HCS users and caregiver database, and also other functionality, while the HCS can control the Ageinghome apps. In order to provide a connection which provides adequate protection of security and privacy at an acceptable level of reliability, a dedicated and isolated end-to-end network slice will be established. Only devices equipped with SIM card owned by the hospital can be authorized to connect to this healthcare network slice. While IoT devices are in general not allowed to, some smartphones may be permitted to have simultaneous connection to the public network slice, depending on the security policy of the hospital. Since the edge cloud is in the same area as the elderly home, very low latency can be achieved, thus making it suitable for welfare technologies. Both the security and privacy are considerably enhanced because of communication between sensors and the Ageinghome do not have to traverse the entire mobile network, but only a short path between the gateways and the edge cloud. In our paper, we also present a business plan containing the vision, the mission, product service solutions, customer market, organization and management, and go to the market plan, the plan of financing and funding. If you're interested, you can read it in our paper. Here is a figure showing the proof of concept implementation. A cloud radio access network is communicating to a cloud open air interface virtual evolved core network called VEPC. We have separate HSS databases, thus achieve restricted communication. And the association of specific users to a specific network slice is achieved at the radio access network layer. Now the conclusions. In this paper, we have presented Ageinghome, a welfare solution which enables newly hospitalized elderlies to come home by providing a secure, privacy-preserving and reliable 5G network slice and an extensible and adaptable framework, allowing the selection and customization of needed welfare technologies and services. The solution also enables the reallocation and reuse of equipment when they are no longer needed. Validation methods and the business plan are elaborated in the preparation of the future trial. Although the current proof of concept is working, only functional and limited performance tests have been done. Further tests and validation done with real users must be performed to identify weaknesses that can be improved, ensuring the adoption of Ageinghome for the benefits of the elderlies. The most optimal validation would be a field trial with a limited set of elderly at 1 or 2 municipalities for a period of 6 to 12 months on a real 5G mobile network, which is made available by the Horizon 2020 5G Venice facility pilots in Norway. For the realization of such trial, funding is required and efforts have been put to elaborate both national applications and EU project proposals. In addition, contacts and dissemination activities towards elderly organizations and municipalities should also be pursued. Thank you.